Alright guys, today we're going to go ahead and talk about arcs and chords. And this again is going to be pretty definition and theorem heavy. Okay? So the first thing we'll get down is our central angle. Central angle is an angle whose vertex is the center of a circle. Alright, so you can remember it central and center. So if you guys look at this drawing here, angle ABC is going to be a central angle because of the fact that the vertex is right here at the center. An arc is an unbroken part of a circle consisting of 2 points called endpoints and all the points in between. Basically, guys, it's going to be a little sliver of your circle. Okay? So here are your endpoints and all the points in between. A minor arc is an arc whose points are on or in the interior of a central angle. So your minor arc is going to be named with 2 points, arc AC. And then the other thing is the measure of arc AC is equal to the measure of the central angle. So if this angle is 60 degrees, the measure of this arc is also going to be 60 degrees here. Okay? Your major arc are going to be the arc that lies on the exterior of the central angle. Okay? So your major arc here would be ADC. You can remember minor, little, major, big. Okay? Interior and exterior. So minor arcs may be named by 2 points. Major arcs must be named by 3 points. Okay, so you can actually use 3 points to name a minor arc, which you'll see in a second. Major arcs, they have to be named by 3 points. That way, because if I said arc AC, you wouldn't know if I'm talking about this one or this one. So if I say arc ABC, that tells you to go around the block, or excuse me, ADC, to go around the block this way. Okay, and then the measure of arc ADC is going to be 360 minus that minor arc. Okay, so if this was 60 degrees, guys, this is going to be 360 minus 60, so that would be 300 degrees. And then you have your semicircle. The endpoint, if the endpoints lie on a diameter, the arc is a semicircle, which of course is going to be 180 degrees. And it will go through the center there. The endpoints, if you connect the line, it would go through the center. Okay, so here you guys will see some problems like this in your homework. We want to find the measure of arc BC. So this is the arc BC here. And remember, guys, there's 360 degrees in a circle. All right? This is telling me that rap music is the preferential music for 13%. Okay, or the music sold, 13%. So this is not 13 degrees. This is 13% of 360 degrees. Okay? So watch out for that. So it's actually going to be 46.8 degrees. 13% of the whole. Okay, so adjacent arcs are arcs of the same circle that intersect at exactly 1 point. They're next to each other, all right? RS and arc ST are going to be adjacent arcs. And then we have something called the arc addition postulate. And so the measure of arc ABC is the measure of arc AB plus the measure of arc BC. So if we look at a problem here, we want to find the measure of arc CDE. Well, I know that this is going to be 90 degrees. What is this? 18 degrees, because these guys are vertical angles. So it's just going to be 90 degrees plus 18 degrees, which is going to be 108 degrees. Okay, a couple more theorems, guys. These aren't hard, but you got to keep your head straight on them a little bit. So the first thing, congruent arcs are 2 arcs that have the same measure. So your central angles here have the same measure. That means the arcs are going to have the same measure. Okay, they're going to be congruent. So in a circle or congruent circles, congruent central angles have congruent chords. Congruent central angles have congruent chords. Congruent chords have congruent arcs. And congruent arcs have congruent central angles. Congruent arcs have congruent central angles. Okay, so any of these allow them another piece of within that to be congruent. So a quick little proof to go through this. You guys don't have to do any proofs, but I like this one. It's a nice tight little proof that pulls in a couple things that you guys have seen in the past. So I have angle ABC, guys, and that tells me that that's congruent to angle DAC. All right, these guys are congruent here. So what we're basically going to prove is that congruent central angles have congruent chords. All right, so These guys are congruent here. That's a given. So then from here, I can go ahead and I can say that this is congruent to this, which is congruent to this, which is congruent to this, because they're all radii of the circle. So of course they're all congruent. Well, some of you guys may already see what's going on here. Can I say that these triangles are congruent? Sure I can. Side angle, side. Well, if the triangles are congruent, then I can say that, I did that last time too. If the triangles are congruent, then I can say that all the sides and all the angles are congruent to each other. You guys remember what that is? Congruent parts are congruent, triangles are congruent. Or corresponding parts are congruent, triangles are congruent. So CPCTC. All right, let's go ahead and let's use some of these. These are kind of problems you're going to see in the book. Like I said, y'all won't have any proofs, but I thought that was a nice little type proof, and it brought together some stuff that we've done in the past. A nice little reminder. All right, guys, it's telling me here that chord RS and chord TU are congruent to each other. And it wants me to find the measure of arc RS. Well, we know that congruent chords have congruent arcs based on our three properties we wrote up. So that means that I know that 3x is going to equal 2x plus 27. Go through your calculations and you get x equals 27. However, it wants me to find the measure of arc RS. Okay, so I plug that 27 in, and you get 81 degrees as the measure of arc RS. Using another one, it gives me that these circles are congruent. Okay, circle B is congruent to circle E. And then it also tells me that arc AC and arc DF are congruent, which is what it gives me here. And it wants me to find the measure of the central angles. Well, I know that congruent arcs have congruent central angles. So I know I can set these guys equal to each other. Solve for y. Alright, and then it wants me to find the measure of angle DEF. Theoretically, they're congruent. It doesn't matter which one you plug it into. That'd be a good way to self-check. And so then you end up getting 7 times 24 minus 43, and that's going to give me 125 degrees. Okay? So again, just using those different properties, the central angles, the arcs, the chords. All right, 2 more, guys, and this is where we're going to end here. In a circle, if a radius or diameter is perpendicular to a chord, okay, if it's perpendicular to the chord, then it bisects the chord in its arc. In a circle, the perpendicular bisector of a chord or radius is a radius or diameter. All right, so basically, radius CD is going to bisect EF, okay, because of the fact that it's perpendicular to it. It's also bisecting arc EF. Conversely, if JK, here's a diameter, okay, or you can say the radius AK, all right, is a perpendicular bisector of GH, that means that it's going to be a diameter. Okay. So let's see how we're going to use this. Using radii and chords, using that theorem that we just talked about. We want to find BD. Okay. So here it tells me that it's going to be perpendicular. Because of the fact that it's perpendicular, we know that it's going to bisect it. Alright? So now, you guys will notice, this is not going to be drawn for you all the time, but you guys will notice that what's happening here, I'm creating a right triangle. Because I'm creating a right triangle, I know this radius right here, if y'all can follow, is 5, 2 plus 3. Well then what can I say about this hypotenuse? It's 5. So I'm going to take this triangle just to make sure we're all on the same page, and I'm dealing with this guy right here. This is what I want to find. I want to find x. Well now, Pythagorean theorem, 3 squared plus x squared equals 5 squared. Solve for x and you get x equals 4. Okay, so because of the fact that this is 4, that's not my answer. What am I trying to find? The length of BD. So the length of BD is going to be 8. And it didn't give me any units, so I'll just leave it as 8. So to recap, I know that these bisect based on my theorem, so I went ahead and made those marks. I used my Pythagorean theorem. I used my radius, which is the same here, to find that x and plugged it in and doubled it. So this is what we'll be working on tomorrow, you guys, and we'll do a quick recap.